Dear students, again this is Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering, to deliberate about the surface tension. We are in the topic of properties of the fluid. So when we speak about the properties are very important entity of the fluid, decides where to apply, how to apply. So far we have seen important properties like density, surface tension and vapor pressure. Now we are getting into the property surface tension. So it is simply defined as ability of liquid to act like a thin flexible film. How long it is able to act like a thin film? எவ்வளவு நேரம் அதனால thin film இருக்க முடியும்? That ability is said to be the surface tension. Surface tension. So its unit is Newton meter. We can see in a tap, water has a drop which is elongating to certain distance. After that also it is elongating to more distance. Some more distance it is rupturing and rupturing falling down. So how long it can able to act as a ability of flexible film? எவ்வளவு தூரம் அது எலாங்கேட் ஆகி அதனால ஒரு லிக்விடாவே அது கண்டினியூட்டியாவே இருக்க முடியுது, கட் ஆகி வெளியே விழாம. That tension is said to be surface tension. That kind of tension is ability is said to be surface tension. It is indicated as sigma having the unit of Newton per meter. Newton per meter. So what is the application of this? Its application is when you go for a space shuttle or any innovation, you are using a fluid, that the fluid must be designed in such a way that it should not disturb the actual system. It should not disturb the actual system. You just think, inside a laptop, air is going inside and coming out. When it is going inside, if it is not moving, that means if it is not moving and it is like a thin film, it is staying there itself due to some other reason. So the heat will not be taken care. Your laptop will get hanged, your computer will get hanged, your iPod will get hanged. That means it will not work. So the property of the fluid has to be, property what you are choosing has to be adapted for very well suitable for your project. Such a way that you have to choose. That is very, very important. Correct. So just think that God has designed us. We are having water over our eyelashes. Have you noticed it? Every blink you are flushing your eye. From where that water is coming? There is a motor inside which circulates the water inside over the eye, so that your eye is not dry. When it is not dry, you are able to see. So this is also the property which is defined by this surface tension, the fluid which is taking care of your eye. Okay, so the design is like that from the God. It's application given by God to us. So we have to think in different way for our project. Next slide. So next is capillary. Capillarity that we know, when we insert a pipe inside a big beaker, if it is a water, it will rise up. If it is a mercury, it will fall down. You can see this is a mercury. This is a water. It is over the range, water. It's below the range of the mean level. It is due to concave and convex shape noticed in the water as well mercury, which is very important parameter to be noticed. When a question arises, can I drink water in a space shuttle? You can drink water, no issue. But it will not flow as you said. You might have noticed in several videos, YouTube or in our my class also. When you drink water, you have to put like this. It will follow the side circuit and reach your mouth inside a space shuttle. Because of its altitude, because of its change of position, it is reacting like that. That if you use mercury, how it will react? That has to be noticed. So based on the fluid, the property, the application, what you are going to choose should be carefully dealt for a particular application. For that purpose only, this topic is given purposely to deliberate about the concept. Now let me come into the shape here. Here, this is a water, this is a mercury. In the water rises more than the mean level, container level. even for small glass or bigger glass tube. Whereas here any kind of glass tube, the mercury which is falling below the average level, That means that mercury has high density. High density fluid always fall below the average level. Low density fluid rises up. Low density fluid rises up. And another reason is its cohesion and adhesion property. Cohesion and adhesion property. And another reason, it creating the shape, you can see here, the shape is here like this. Here the shape is like this, convex and concave. It is due to property. It is due to fluid property. Next slide. So Pascal's law. Let me come to the law. Thank you. Let me see Pascal's for next session. Thank you.